Thank you. I think I've met a few of you throughout the conference, and it's been an awesome conference so far. And I'm really glad to be talking on this subject because I think when I first came across the technology that I'm about to describe to you, I was quite amazed that it didn't exist in every part of programming. I wish it did, because it's so easy to build large, complex applications in such well componentized and well mapped out components for your application. So we're going to look into a bit of what's called component architecture. Component architecture is go to the next slide. Component architecture is a way of abstracting your code. You might be familiar with things like object orientation, where you take one class and then you you inherit from that class, and you gain all of the benefits of that class, and then you can add in extra functionality. And that's a way of abstracting your code, and a way of, you can call a method, but if you've inherited it and you've got a new object, you can change around and customize the kinds of things. So this is a truck with Lego bits, and it's kind of what I think of when I think of component architecture. If you've ever looked at source code for projects like Clone, you'll realize, wow, there are so many components to this thing, literally in the hundreds and hundreds of packages that can fit together to form these things. So, indirection. We love indirection and simplicity as programmers. If we just high level say do something and then it gets done somehow. We don't even want to know how it gets done sometimes. We just say do something, and then we just hope that the machinery underneath it does something, or that if it doesn't do the thing that we want, we investigate it, we find the component that we want, and then we can override it. Okay, so when we're talking about component architecture, you can think of it as a way of indexing code that you've written across all of your components into a centralized registry. And then when you need to access some component, you query the registry based on what objects you have and what kind of thing you want. So it's a way of searching for the code that you want. And in that way, you can configure the registry in such a way that for a different set of objects, you get a different outcome for what you want. This is based on the idea of interfaces. You don't usually get interfaces in Python, but in this case you do. So an interface is something that an object declares about itself. So I can do this, or I can do that. It's a contract with your program that guarantees that thing will do what you want it to do, in a sense. So here, this is the basic adaption pattern, or the basic pattern of component architecture. You have an object, and then on the other side you want an interface that does something, and then in between you get an adapter that changes that object into that thing that you want to do. So that's the diagram down the bottom there. And that's essentially, that adapter there is essentially what you want to be querying your component architecture for. So on the left-hand side, you've got the object. It might have a number of interfaces. On the right-hand side, you've got the interface that you actually want. You give those two things to the component architecture, and it will return you the thing in the middle. Sounds kind of complicated, but we're going to do an example, and it's live, so I hope it's going to work. No, there's another slide. It has a really neat way of configuring itself, which I'll show you in a second. ZCML is an XML way of describing how things relate together. And Zope component architecture will take that ZCML and put all your classes and all your interfaces into that component registry, so you can get the adapter that you want. You can find the code that you want to do the things that you want. Okay, let's do an example. So there's three things we need to be remembering. There's interfaces, which say something about our object or our code. there is the adaption process, which is this registry that sits in the component architecture that you query, and it gives you the code. And then you've got this idea of configuration in this XML format. It describes your application at a fairly high-level view. So component architecture is zoomed out quite a bit, and it's kind of explaining the big chunks of your code. Not so little as a method, as in object orientation, but on the object level. Okay, let's go for my demo. So I have a very, does that fit on the screen? I hope so. A very rudimentary application. It keeps a total of 4 bookmarks in this class called bookmarks, which inherits from list. So we are using a sense of object orientation, and there we are, it just adds 4 bookmarks there. There are 2 kinds of bookmarks. There's just an ordinary one up here, and all it can do is store or retrieve the URL. It can open it in the browser, and I've got a little thing here to make it pretty when we print it on the screen. And then there's also a secure bookmark, which all it does is it asserts that the start of the bookmark begins with HTTPS before it stores it. So that's our simple application. And if we run that, we can go into my object orientation thing. I'm going to restart this kernel. Nope, that's not the key, that's the one there. So I've created bookmarks, and there we have the first one and the second one. And then it has a method on the bookmark. So if I grab the first one, I can do open in browser, which should open up in a new browser. And hopefully we've got enough internet to get the Sydney Morning Herald on the browser. Okay, so this method here, open in browser, which is the kind of the central activity of this application. If you would like to override that method, how would you go about doing it? You might think, it would be a good idea. Maybe you could subclass bookmark and then change that method, but you'd have to recreate secure bookmarks, and you'd end up pretty much rewriting the whole application in any case. You could fork it. You could fork the application and rewrite it, but then you increase your maintenance cost. You could monkey patch that particular method, so you could run some kind of way to override that method, and then that'll work for secure bookmarks as well, but monkey patching is a bit ugly. So we have this other concept of component architecture, which I'll show you. And what we're going to do is we're going to define an interface that kind of encapsulates that activity, open in browser, as an interface, or kind of a general concept that we want to use. So I have an interfaces file, and you import from Zope interfaces, which is the implementation of interfaces we're going to use. And the general activity I want to be describing is I open bookmark. So we want to be able to get a bookmark, find this interface, I open bookmark, and browse to that bookmark. So let's try that out. This way. Where's that? Okay. Now to be able to do that, we've got the interface, which I've described to you already, and then you need to connect it up with the ZCML. So this is where you describe that interface and how it connects to other things. So this is the ZCML, the adapter, and then you define where you can find an instance of that adapter, which is in this particular class here. It provides that interface there, and it is for that object. You can see this is kind of like the registry setting that will be searched for when we call for this adapter. If we look at this particular adapter, I have it in another file, which is here. All it does is takes the original object as just a context variable, and then we call the Chrome application to open up the URL. So we can try that. Let's go. So we run the ZCML configuration, and that should load all the code that we've put in there. And then we will find that interface marker, the IOpen bookmark, and with the first bookmark in that list, we're going to query and get the adapter and then just browse to it. And so that should actually find the code and then execute browse. So if I click play, there you are, you did that. And then the other way of doing it, which is a bit more verbose, is to use this method getAdapter, which is in the zope.component library. And that is the same as this, except it should return it there, and then we can browse it. So we'll try that. And it did the same thing. So it goes to our favorite banking page, ING Direct. Okay, so now we have our simple application. We've componentized it a little bit. We've used Zope component object to define an interface, and now we actually want to extend it. So we want to build a plugin that, in this case, we're going to build a plugin that deals with the secure bookmarks in a different way to the non-secure bookmarks. So the first thing I need to do is I'll write an adapter that does a different thing. So this adapter opens a bookmark in Firefox instead of Chrome. And so I want to use this adapter for a different situation. And so that would require a different entry in our ZCML, which is the first one on the top. So instead of the object that it's going to provide the adaptation for being bookmarks.bookmark, I'm actually going to provide it for bookmarks.secureBookmark. Now, the way the adaptation process will work is it will look at the adapters that are available and pick the most specific one. Now, if it picks the other one, that is not as specific. If you look at it, bookmarks.bookmark is the parent class of bookmarks.bookmark secure. And because I'm specifying it into a narrower range of classes, this adapter entry will actually win for the case of secure bookmarks. So if I go back to my base configure, ZCML, I can remove this include this comment here, which will include this package that I've created that has this new ZCML in it. So I'm going to save that. Go back to this, reset my kernel so I can start again. And I'm going to load my ZCML configuration again. And this time, this one is the first bookmark, which is an ordinary one, so that should open in Chrome, as we like to see. And then the second one is the secure one, so that should actually open in Firefox, which it's done, which is excellent. So we've extended our application by providing another package. It's got its own ZCML. It overrides a little part of the configuration by saying, I'm more specific for the secure bookmark, so use me instead. Now I'll quit that. Now, say for instance, you are aware of the fact that there's this Chrome or Firefox decision that will be made, and you actually, even though the configuration says use Firefox, I actually want to specify using Chrome. So what we can do there is we can add a second entry into our adaption registry, which is actually almost, it's identical with one exception to the one in the base for bookmarks, except we've added a name for it, Chrome. So that if we actually add a name into our get adapter, we should, theoretically, restart. can add names into our things. It's kind of like an extra parameter to that. So it's taken the other entry there. So that's the component architecture demonstrated using the adapters and the plugin. I'll just briefly describe that this is used in a number of applications like Pyramid. Also, if you've ever had anything to do with Grok, it's used in that. And most notably, it's used in Plone. Plone has a very interesting use of it. It has the objects are content in themselves. So you have a range of content. You have files and images, and you have pages and all kinds of custom content that you might have in the base. And you also have a request. So a request will come in, there'll be a piece of content, and then you've got those two objects. But what you actually want is an object to render a page. So there is an iBrowser view interface that you query for into the component architecture, and you say, I have these two objects, a piece of content and a request, and I want something that's going to render a page. And so based on the aspects of those two objects, you can get something that'll render the page in your various particular context, which is very useful. So you can produce many kinds of different views for different kinds of content, and if those views don't exist, then you can always back down to the default views that are provided by other components. I think that's all I have for at the moment. We can jump into some time for questions if anybody's got some questions.
So we have several minutes for questions, so whoever has a question, I'll bring the mic.
Yeah.
One here.
So this is a design pattern that's
can you speak louder? Sorry.
So is this a design pattern that's used in other programming languages that it's borrowed from, or is it something that's unique to Zope?
I haven't seen it.
Okay.
It's the first time I've really seen it. It's yeah, I wish it was in other languages.
Right.
It's interesting because you can implement it in code space. It doesn't necessarily need a
you don't need to use
language
that
level
library.
Sorry?
You could make your own.
So
fairly easily. Or?
It's not too hard to make. Yeah.
Okay.
I have used it in Coca, or in the Objective-C. I wrote a quick one because I was like, I really need this. This would be awesome to use in this kind of context as well. But I'm unless anybody else is aware of component architecture in another context, I think Zope has got lots of brilliant things that they haven't documented very well. So it's there. It's just waiting for people to unpackage it. And
so it's used by Zope and Pyramid, the main ones?
More at an underlying level in Pyramid.
Yeah.
But you can use it in Pyramid for, yeah. I'm not a Pyramid expert though, so yeah.
Any more questions from the audience? All right, in that case, thank you very much. For your talk, we'll give you a special blend of Norwegian blue coffee beans and a PyCon AU mug to drink them from. Please join me in thanking again.